So Lua scripting in DFlow.
Mm,
It's like this whole other side of the software, isn't it?
it really is, yeah.
Like you can build these incredible simulations, right?
Yeah.
But at a certain point, you hit this wall.
Yeah.
Like if you want to do something really specific, really unusual,
Right.
how do you even begin to tell DFlow to do that?
You've hit it right on the head, and that's where Lua scripting comes in.
This is what we're going to deep dive into today.
Yeah.
You sent over some excerpts from a DFlow training syllabus. It looks like it's time to go beyond the standard tools. Yeah.
Exactly. And it's like you've discovered the secret language to talk to DFlow directly more than you ever could just using the interface.
And tell it to do some really complex things. Now, I know what some people might be thinking, right? Lua scripting, I need to become a coding master. But from what I'm seeing here, DFlow uses a specific set of Lua, right?
Yeah, absolutely. It's all tailored.
So it's not like you're building the language from nothing. You're learning the commands for this environment.
It's like you said, working smarter, not harder. And Lua, it's known for being fast and pretty easy to learn, even if you don't have a coding background.
That's reassuring, because I definitely don't. Okay, so let's get into some basics then. I'm seeing this phrase in the syllabus, value types. Is that just a fancy way of saying the kinds of data you can use in Lua?
Yeah, exactly. It's all about how we represent that information. So like numbers, for instance, right? You'd use those for things like speed, distances,
Makes sense.
strings, that's for text, so object names, messages, that kind of thing.
Okay.
Booleans, those are your true or false, yes or no states.
Gotcha.
And then you've also got tables.
Yeah, and the syllabus, it compares those to spreadsheets.
Yeah, I like to think of them like that. They're really helpful for organization. So let's say you're simulating traffic, right?
Okay, yeah.
You'd need to track each car, its speed, its direction, maybe even its color. Tables give you that structure, like a spreadsheet, but right there in your code.
So instead of having code sort of all over the place, it's
Yeah.
in these neat little containers.
Exactly. Organization is key.
And speaking of organized, the syllabus is very specific about how you should actually structure your Lua code.
Mm-hmm.
Header, variables, functions. Is that just to be tidy, or is there a functional reason for that?
Oh, no, there's a very important reason for it. Think of it like a blueprint, right? It's more than just being tidy. It makes your code much easier to read, easier to debug if something goes wrong, and importantly, easier to share.
Yeah, especially when you're working on something complex.
Exactly.
It's like good grammar for coding almost.
That's a great way to put it. And just like good grammar makes it easier to read a sentence, the structure, it helps DFlow understand what you're trying to tell it to do.
And it can make the whole process less intimidating, I bet. Like if you're new to this whole world of coding,
Absolutely.
having that framework there can be really helpful.
It's like having a recipe instead of just starting from scratch every single time, yeah.
Okay, that makes sense.
Yeah.
So speaking of frameworks, I was really interested by the section on module actions. This is where it seems like your Lua script can actually react to what's happening inside of DFlow,
Exactly.
which is amazing.
Yeah, that's where you get into this event-driven side of things. It's not just writing static instructions. It's about making the script react in real time to what's going on.
So for example, if I wanted something to happen in my DFlow simulation, but only when a certain object reaches a certain point,
Yeah,
I could use Lua to do that.
exactly. You can set it up to listen for that event, that object reaching that point. And when that happens...
Like a trigger almost.
Exactly. It's a trigger. And then your script, it knows, okay, it's time to do this now.
That's so cool. I see here there are different event types listed. Start, reset, action. There's even a whole tutorial on using module actions to control a billboard text.
Oh, yeah, that's a good one.
Can you give me an example of how that might work?
Sure. So let's say you're creating a virtual city in DFlow, right?
Okay.
And you want the text on a billboard to change depending on the traffic flow.
Okay.
You could absolutely program that with a Lua.
Wow.
So if the traffic flow hits a certain point,
Yeah.
triggers that action event, the Lua script, it could tell that billboard, okay, time to show a traffic warning.
So smart.
Yeah.
And even when you reset, the billboard could show something different maybe.
Exactly. Maybe a welcome message or even like cycle through different ads.
It's like another layer of realism. It's making those environments really come alive.
For sure. It's all about making it feel dynamic.
And to make those events even more powerful, you can use something called metadata.
Right, metadata.
This feels like we're getting into some advanced stuff now.
It's not as complicated as it sounds. Think of it as sending extra information along with your event trigger.
Okay.
Like you're sending a message along with your invitation.
So give me an example. I'm trying to wrap my head around this.
Let's go back to our city. Imagine you're simulating fireworks.
Okay, yeah.
And they're triggered by, say, the sun setting in your D-Flow environment.
So the action event would be the sunset.
Exactly. But you wouldn't want the fireworks to just go off randomly, right?
Right. They need to be launched from somewhere specific.
Exactly. And this is where metadata comes in. You could attach the coordinates of, say, a launch pad as metadata.
Oh, I see. So when the sun sets, the Lua script not only knows to trigger the fireworks,
Right.
it knows where they should be launched from.
You got it. It makes your events more precise, more context-aware.
Wow. It's all about the details.
It really is. And that leads us to something that takes things even further, collision detection. Because sometimes you don't just want actions to be triggered, you want your D-Flow simulation to react to things actually interacting.
Collision detection. This is what I was excited about. This is where things get really real.
It's like going from watching a movie to actually stepping inside the screen, isn't it?
Totally. And with Lua, we can make those collisions really matter.
Exactly. We can get data from those collisions, actually use that information to make things even more realistic.
It's like having a sensor built into every object telling you exactly what happened.
That's a great way to think about it. And the syllabus breaks it down into 3 main data types that we can get. First up, the object list.
Okay, that one seems pretty self-explanatory. It tells you what collided with what.
Exactly. So let's say you have cars, bikes, pedestrians all moving around in your D-Flow simulation.
Right.
The object list would tell you precisely which ones were involved if there was, say, a fender bender.
No more guesswork.
Yeah.
I like it. Okay, what else do we have?
Then there's the position list. This gives you the exact coordinates right there in your D-Flow space where that collision happened.
Super useful. So you could, like, create a visual effect at the point of impact.
You got it. Sparks, smoke, whatever makes sense for your simulation. And then the most intriguing one, I think, the normal list.
Okay, that one sounds a little more technical. I need you to break that down for me.
Basically, the normal list tells you about the angles involved in the collision.
The angles?
Yeah. So instead of, say, a ball bouncing off a wall randomly,
right,
you can use the normal list data to make sure it bounces off at a realistic angle based on actual physics.
Wow, that's incredible. We're not just scripting actions now. We're defining how this whole world behaves.
Exactly. You're creating the rules of physics for your virtual world. And the thing is, we're still just scratching the surface here. The syllabus even talks about using Lua to create and delete objects while the simulation is running.
Wait, hold on. We can make entirely new objects appear on the fly.
That's right, and make them disappear just as easily.
My mind is blown. The possibilities are endless.
They really are. Simulations that change based on what the user does, environments that react in real time. That's the power of Lua scripting in D-Flow.
It's incredible. Lua really takes D-Flow to a whole new level. This has been amazing. Thank you so much for walking me through all of this.
Absolutely. It's been my pleasure.
And for everyone listening, if you ever thought D-Flow couldn't do something, well, Lua scripting might just be the key to unlocking those possibilities. Until next time, happy simulating.